Hello together. My name is Bernd Dötterl. I'm from DMG MORI in Fronten. It's in south of Germany. And we will make the presentation together with my colleague Walter Cox. He is sales manager here in this area on behalf of DMG MORI Netherlands. When I say DMG MORI is DM. G is standing for Gildemeister, and Mori is our Japanese counterpart from Mori Psyche. So in principle, we are 4 companies joined together with an experience about more than 100 years. Today, we got the honor to join here the seminar, under the lead of the Knowledge Sharing Center. I will give you some general overview about DMG MORI. Our special branches are turning and milling. We can do mill turn, or we can do turn mill, mid-mill, everything is mixed up. We also can combine it with grinding. We have the ultrasonic technology. This is also very interesting, especially for ASML Berlin. It was Berliner Glas, but ASML took over. They have more than 80 machines in operation for the ultrasonic applications. And here ASML Berlin is our direct customer on behalf of DMG MORI. For the rest and for the classical parts, I will explain later our position. Laser tag, is also interesting for sharpening of tools and for cutting and also for shaping and additive manufacturing. I will at the end show you 2-3 slides for additive manufacturing. That means 3D printing with metal materials, and we also have hybrid solutions. That means we can build up the material and we can cut it on the same machine without new setup or without changing the machine. I think this can be very, very interesting for the semiconductor industry, especially here for the lithography machines, because here you can create very, very crazy designs, but I will come back to this later. Our topic is also automation. This is one of our, let's say, topics, meanwhile, same as digitization. Later we will talk about PMI, also from Mito Toyo, PMI, and of course digitization. We are very open and we are willing to go ahead with the new trends in future, also based on PMI models, where we see big benefit for all the later stages during the process. We have technology excellence centers for aerospace, die and mold, and we also will create the same one for semiconductor. We have training and service. We have a presence worldwide in 79 countries. The green one are the original DMG responsibility. The red ones are under the lead of Japan. We have 2 headquarters. One is in Tokyo, under the lead of the big boss, Dr. Mori. And we also have 1 headquarter in Germany, in Bielefeld, under responsibility of our chairman, Mr. Tönnes. In total, we have roughly 12,000 employees, and we deliver roughly 12,000 machines per year. So 1 employee, 1 machine. Here at ASML is maybe 1 machine, 100 employees or something like that. There is another relation just to get a feeling. We also double stock listed. We have DMG MORI AG in Germany, and we have DMG MORI CO Ltd in Japan. We have in total 14 production plants. Here also you can see the original green one from DMG, the red one from Mori Psyche. We have the cooperation now since 2009, so it's already 13 years old and is working really very well. When we have a look on the brochures, of course, automotive, it was already mentioned by Sarah Tizit, is changing into the electromobility. That's great for us, because we can equip all our machines with the turning function. And for the horizontal and for the engine, it was normally enough to do it on a 4-axis machine. And now the parts becomes with a rotary shape. And this is very attractive for us, because then we can do turning and milling on 1 machine. As I said, I'm from DMG MORI Fronten. I can show you again, this is here the factory in the south of Germany, number 2. This is the biggest factory under the lead of DMG. We had a technology day end of October. Mr. Granin was joining and also holding a keynote speech. And so, it's a good cooperation. And we in our factory, we produce only 5-axis machines. You will see later in the video the meaning of 5-axis machine. Aerospace, we are very, very strong. We have here an excellence center. Excellence center means we get a drawing from the customer and then we check the complete process. The strategy, the programming, the tooling, the coolant, the software, the machine, of course, itself. Mostly aerospace machines equipped with a lot of special options because this is also high class of machining, especially the engine parts made from titanium or Inconel. We have die and mold. This is our origin. We have mechanical engineering. We have the power generation. And we see also big potential in the business of semiconductor. Normally, I explain always the story from Adam and Eva about semiconductor, but I think this I don't need to do here today. I go into the EUV machine directly. I think you know very well the content, and we see many, many interesting parts. We have the metro frame, we have titanium parts, we have the wafer stage, we have the illumination frame. This goes up to 5 meters in the next generation. We have the complete illumination chamber. We have the light source coming from Trumpf. This is also a very interesting customer for us. And we see the chucks. And this is just a small selection out of all the parts what you are producing. But we from DMG MORI, we can offer the right machine for all the parts. We have the big portal machines up to 6 meters for the big frames. We have dual block machines for titanium frames. These are premium machines. We have monoblock machines for the smaller parts. And we have the ultrasonic technology for hard brittle materials. We can equip all machines with the mill turn function. That means we can do milling and turning on one machine. This is very interesting for such an optical housing. Here we can make 5-side machining of the complete outer shape, and we can do turning of the cylindrical center bore. We also can equip our machines with micro precision to increase the accuracy of the machine up to a very, very accurate level. And ultrasonic means the spindle is applied with a linear oscillation so that you get a picking effect. And with this picking effect, you can machine glass, ceramic, or zero-dur. For all your mirror carriers or mirrors itself, the effect is same like you know it from your home drill. When you want to make a hole in the concrete without the hammer effect, nothing happens. Then you switch on the hammer effect, and it goes in very easily. This is the same effect here on ultrasonic. This is an own company. And normally, they use one of our machines as a basic machine, and they just enhance the spindle in regards of ultrasonic. I'm here responsible for semiconductor for 3 years now. And I have here the global view about semiconductor industry. I know here in Holland and in Europe and also in our company, many people are thinking when you buy the machine from ASML, then you can produce the complete chip. But this is only one part of the process, the lithography, the exposure of the chips. There's also the upstream process and the downstream process. And for the upstream process, it's called deposition, that you add a new layer on the wafer. This is for us also very interesting, but here the music plays in the US or Southeast Asia. Just to give you an overview about our machine capability, they also need very big frames machined out from one piece. They have wafer stages with a circular shape, perfect for our mill turn machines. They have graphite carrier. The wafer needs to be heated up to 1000 degrees Celsius. Therefore, you need graphite. This is also perfect for our machines because this happens by dry machining. There is no coolant used. Dry machining and chamber housings. And over the last 3 years, we got so many requests about the chamber housings. The distributor housing is here the central part. The wafers go in from the front side through the distributor housing. The wafer will be distributed to the chambers, and here happens the process. Deposition, etching, cleaning, ionization. The principle is always the same. And the machines always look same, and there are so many kind of variants regarding chamber housings. And yeah, we from DMG MORI like this part very much because it fits perfectly on our 5-axis mill turn machine. So here the same, we have the big machines for the big parts. We have the chamber housings. This is a perfect part. We also have a video, but this is not prepared here for the presentation today. There you can see milling, turning, grinding. Maybe we can distribute a link for that. We have the stages and we have the carrier parts. Here is one machine for etching. Here we have the base part. We have the central housing for distributing the wafers to the chambers again. We have the chucks. The chucks are always handling the wafers into the different housings. The chucks are mostly made from ceramic to be resistant against acid. And yeah, we also have the chamber housings. So now I repeat myself. This is just a very quick view about the complete business and what we are covering. And we are very flexible. We have universal machines. And yeah, if it is becoming more sportive regarding material, when we talk about titanium or stainless steel, or when we talk about high accurate parts, or when we talk about multitasking, milling, turning, grinding, then we are the right choice. One summary from my side, then I will hand over to Walter, and then later I will explain the dummy part, what we have seen in the other room. I don't need to explain you the foundries producing the chips itself. Here, the wafer fabrication equipment is where you are. You see here some other names, and we, of course, try to touch or to catch all these names. We also have good relations to applied materials. The nice thing is you have no competition to the others. They are completely different business, what they are doing. And we have the sub-supplier. And except ASML Berlin, here are you our direct customer, but we supply our machine tools here to the complete supplier network. And this supplier network, here we find our customers for the classical machining. Not hard brittle materials, but aluminum, steel, titanium, stainless steel. We find here the customers. And I know we have already a very good standing in this business. But it's a big, it's a big honor for us that we have the contact directly to you and also to Mr. Sprengers, and that we could develop such a dummy part, as you will see later, together. The beginning of the dummy part, Walter will explain because he has the roots here in Netherlands, and he has the contacts, and here everything began.
Yeah, thank you, Bernd. Also, thank you, ASML, for inviting us for this event. Very nice to be here. What I want to tell you about the collaboration between KSC and DMG MORI and how it began. I think about 2-3 years ago, we get in contact with KSC, and we see an advantage as a machine supplier to give our knowledge about milling, turning, grinding, and that kind of machining together with KSC, but also together with our suppliers, or the suppliers for ASML, for example, but our customers who are working with our machines. And I think this is a very nice picture from KSC, where you see when a good collaboration is there, you will get a better knowledge from here, from the designers, but also from the suppliers for ASML or for other companies, so our customers. The goal was to get more knowledge between the different parties. And you also see this nice picture on the website from KSC. And we're getting more and more part of it. But there was a challenge when we get in touch with each other, because we have the IP, intellectual property from the parts, which are in different machines. And we have NDA with our customers. We have NDA with ASML. And our customers, so the suppliers, has also NDA. So in that triangle, it's very hard to get all the information together. Yeah. So there was a problem, but for every problem there could be a solution. And after different discussions, we said, okay, maybe it's possible to create a kind of dummy part. And in that dummy part, we can put in all the things which can be needed for the manufacturability of parts. Yeah? We have two bases, yeah, and one base, what we heard directly, let's say, for us 2-3 years ago, is it must be based on a model-based definition. Yeah? For the most of you, it's not a new thing. For some, a few years ago, it was completely new, but in between it's getting more and more general. And that's the way of putting all the information from different parts in one system like MBD, model-based definition. And we had another base, that is the PMI. Yeah? So the product manufacturing information, which should be in the design of a part, of different parts. And how can we use that PMI by programming the parts for our CNC machines? And how can we use the PMI for using it for measuring it? And yeah, let's say in the complete chain for the starting from the design to the end of the producing and the measuring of the parts itself. Okay, what happens after some discussions, let's say December 2021, we get a first ID here from ASML, from the designer, what should be in a dummy frame. So a frame without any IP, yeah, with no NDA, and it should be free for everyone to use it. Yeah, that was the ID. Now, after that, some discussions, we get the first ID from the model, and from the designers here, they said, okay, we have to have some different things into that dummy file, into that first design. Okay, I will not go into detail, but here you'll see some screenshots from the first part what we received from our side. Yep. Then there was the next step to go. Let's say they started in the beginning of this year, in January, with putting in different parts in the design, and in between we have for sure some meetings, and at the end, so let's say at the beginning of September this year, we came together to a model where a lot of things are in which are needed for, in this case, the frame. Okay, when we have a model, then then we get some challenges. Yeah. What was the challenging? Manufacturability. Yeah, we looked to the design and we said, okay, very nice model, but for some parts we need special tooling. And special tooling is, for example, angle heads. Yeah? You see later on in the video from Bernd how it works on the machine. But how do you come to an idea of designing such things into a dummy? part or in a general part. But you have to know that, okay, an angle head is a special tool. Not every machine is able to use angle heads. Not every supplier is able to use angle heads in his existing machines. Yeah? So you have to talk with your suppliers and with our customers. Yeah? What do you need for these angle heads? Do you have a special machine? Do you buy different angle heads? How many operations do you have? Yeah? In the first ID, we calculated maybe for one part, you need 20, 25 angle heads. It's a lot of money to invest, but it's not so easy to import it in every milling machine. Yeah. So let's say after this feedback from our application department, we said, are there different things in the design what you can change to make it easier to manufacture it? Yeah? So what is the purpose of certain pockets or certain surfaces? So after a redesign and a review, we saw that we needed lesser angle heads, and it's more easier to produce it with standard tools on a standard 5-axis milling machine, for example. The easiest part was to use a standard clamping device. And there's a lot of possibilities on the market to buy such a thing. What was the next challenge? And not really a challenge, but we have to create a tool selection guide. So we always looked what kind of standard tooling we can buy or we can use from our department. Yeah, you can buy a lot of tools in all different shapes and on, but the goal is to use standard tooling which you already have or which is rather easy to buy in the market. Yeah. So here you see some examples from different operations in the part and the different tools we needed for that. And the goal was also to use the most latest inventions and developments in the tools. Yeah. And of course, it has to be possible to produce it and to program it rather easy in standard CAD/CAM modules. Also, the review from our application engineering department was some remarks. Yeah. So we reviewed it and give the feedback with remarks where you have to define or what you have to think about as a designer to combine some different operations. Yeah, so that you can manage your complete process and you can manage your complete production by reducing your number of tools. So we gave a feedback with this kind of screenshots and remarks on it. Okay, after that process, we decided, okay, this will be the next complete dummy model. And okay, we decided also to produce it, to get something in our hand. And Bernd is telling something about that.
Okay, thank you, Walter. Yeah, this was the bridge from the idea to the design, and then finally we had the revised 3D model. And today I have here more or less the pleasure to tell you something about the ABC of milling. When you see such a part, every part has 6 sides. And you can machine one side where you clamp it later in advance. And then you have the chance that you can make all the 5 remaining sides on a 5-axis machine. 5-axis machine means that you can move 5 axes. In this case, we have a horizontal milling machine. We can move the tool forward, backward, up, down, right, left. And we can swivel the table, and we can rotate the table. In this case, we can make minus 30 degrees of the swivel range of the table in both directions. That means we also can make negative angles from the bottom side. So here the idea is, when you think about design, you always need the bottom plane, and then this is the first part what needs to be machined. This can also be done on a simple machine, on a 3-axis machine, but you need this plane that we can clamp it. And we clamp the part in the center on 3 pins. This gives us the chance that we can reach the 6th side partly as well. And this is very important because we can finish now all the 5 sides in one step. That means you take out the risk by the operator, moving the part from machine to machine, new adjustment, new setup, new clamping. So this is always important to do it in 5 sides in one step. And when we have a turning shape, if we don't have in this part, like the chamber housing, then we can do the turning also during the setup. And you have also no risk by the operator when they go from the milling machine to the turning machine. So here you see now a video how we start the machining. You can see the raw part clamped on 3 pins. Here we have the roughing tool. You saw how the table swiveled and rotated into the working area, and then we make the contour of the complete part. Here you can see the 5 side. You can make the undercut here. This of course depends how deep is the undercut, because I need to increase my tool length, but I get vibrations and I lose accuracy. This is always important to think about how deep my pockets are. Normally with a 5-axis machine, and when we talk about materials like stainless steel or titanium, we prefer always the solution with short tools. On a 5-axis machine, when we do a pocket, then we can swivel the head and we can go into the pocket with a short tool. Sometimes is it necessary to make it from the top side like a 3-axis machine, and you can see, maybe when you see the part later again, there are some pockets in. Here the pockets are 90 degrees. That means we cannot make this on this way. We need to make it from the top. And the pocket is roughly 100 mm deep. And when we received the 3D model, the first time, the radius here in the corner was 2 mm. So you can imagine 2 mm milling tool with a length of 100 mm. This is the same example when you want to drill with your drill at home in wood, a 2 mm drill 100 mm deep. Maybe 5 mm and then bing, tool is broken. So therefore, it's always important to think about in such corners, is it necessary 2 mm? Because it's almost impossible to machine afterwards. Or we made now a 10 mm radius, and we machined the part completely in roughly 2 to 3 hours. When you have here 2 mm radius, then we need to make it very slowly and very filigrane, and we need 50 hours. That's a big difference. This is always where you need to think, do I need a 2 mm radius in such a pocket? Here you will see that. This is now a strong tool. This is exactly 100 mm what we need. You see we are very close with the tool holder, maybe 5 mm space to the workpiece, that we absolutely not lose stability in the tool. At the end, we will find and normally, with a 2 mm radius, this is not possible. You need to make it very, very slowly and line by line in hope the tool is not. This is absolutely process safe in case it is. Then it's always very difficult to make inclined surfaces. Of course, we have a lot of inclined surfaces in this part, but this is a little bit difficult. We have a 5-axis machine, we can do it line by line. But when you does not have, then you always need a special fixture. This is like here, when you cannot tilt the table or the head, then you need to tilt the workpiece and you bring it in position, and then you can make an inclined surface. And such an inclined surface, here we also need two tools. We need a ball end cutter, and we can only make it line by line. We cannot take a big chip. We need to make it slowly on a very filigrane way. But costs time. Here you can see this is a ball end cutter, and we only take a small chip. And here now we go line by line, we take out. Especially for the patient, because doing the wrapping, we make the big tool and we make steps, but to reach the end result, we need to make it line by line. No, you need it, but maybe in future think about, is it really necessary, or maybe is there any other way how we can get this feature in? The same, I was too fast, the same is for inclined holes. When you look at the part, there is one hole with a very flat angle, in principle through the center of the part. And here in the picture you can already see we need a very long tool that we reach it and that we can go in. And long tool means always the tool starts hanging, the tool gets vibration, and at the end it needs more time, and the risk is higher for an inaccurate result. Yeah, this also you can only with a 5-axis machine. Also, some 5-axis machines cannot. When I said the block, this is another kinematic. There we also have some differences. Because there is the head stronger. But this is always keep in mind. Maybe the next time when you design a machine. So, as already mentioned by Walter, when we received the part the first time, there you can see there are two pillars. And when there is a pillar, then it takes us the space for going in with an angular head. And we did it with angular heads, which are really on the bottom sides, how small you can make it. So that means every hole and pocket and every shape on a 90-degree vertical wall, we need to reach anyhow. And in this case, we can do it only with the angular head. That means we need to bring the tool in a 90-degree position that we can reach it. We cannot reach the holes with our basic machine. This is not possible. This is not so special. In aerospace and all other cases, we use such heads everywhere. We also have an angular head in aerospace where you can make an automatic tool change and everything. Here we change it. When 100 and deep the hole, then it's not possible. We have no space. So for this case, to take care about the costs, we want really to. As already mentioned by Walter, there are many different tools that we have. This is a nice feature. I also want to let you know, this is more or less related to the machine tool side and to the supplier branch where we make the promotion. When you make some ceiling grooves, here with the shape of a cathedral looks like, or here a rectangular, typical rectangular shape, this we can produce very nice by shaping. because normally, and many customers are doing that, and I know there are a lot of quality issues when they make it by milling. When you make the grooves by milling from the top side, then the walls will get the same direction of the tool as the tool is standing. That means the air or the gas can go out. And when you make it by shaping, Schaben, sagen wir in Deutschland, then you have the lines of the tool in the same direction than later the rubber. And then it's better sealed. Here you see outside were done by fish. So this is one thing you don't need to be afraid. I'm not sure is there any remark possible in the hell is fire. Like that. There is a here you can see how big. This is here the shape. Of course, we also can make yeah. That's it from my side in principle. That's the summary. This is what we are taking care. I mentioned we have the big machines for the big parts. We have ultrasonic for ceramic parts. We can machine titanium, stainless steel. We can graphite machining. My colleague, Mr. Benedict Brox, he's responsible for the ultrasonic applications. Here we have the chamber housing. There we also have a very nice video in the YouTube. There you can see milling, turning, grinding on one machine. Also the usage of some technology cycles we call like a touch probe that you can measure grooves while machining, interpolation, turning in a circular way. And yeah, this is also one thing when we talk about technology. And when we get a part and we talk about tolerances around 5 microns. 5 microns on a part with 400 mm like this, then it's normally not possible that you can machine it completely from the beginning up to the end with a constant program. That means we make the roughing, we make the pre-finish, the semi-finish, and before we go into the last cut, we use the touch probe and we measure the complete part, and then we adjust automatically the finish cut. And then we finish it. In process measuring is here in principle the magic. And therefore you need sometimes such an L-touch probe that you can go inside of such grooves as shown here. We have also additive manufacturing. It's called SLM, selective laser melting. This is machine, of course, we have in our program. But this is really very, very interesting. And my colleague who is responsible for additive manufacturing asked me if I can show here 1 or 2 slides, because I know that you, with the EUV machine, your biggest enemy is heat, and the machine creates a lot of heat, and you need to cool down everything. And heat is also the enemy of accuracy at the end. And with the SLM technology, you can, during the print of the part, during the 3D printing, you can incorporate cooling channels. Normally, such a part is not possible to manufacture on the classical way, by milling, milling, turning, drilling. Normally, when we do it on a classical way and we need some cooling channels, then we need to drill it, and afterwards we need to close it by welding or something like that, and maybe we need to mill it again. But here with the additive manufacturing, you can build up the part completely, including all the cooling channels as you can see here. This is a big, big advantage. Also, you can make such parts like that which is 100% customized to all the fittings what you need on your machine or your device. So, Mr. Sprengers, maybe this is our, let's say, wish, or we desire maybe to make one more workshop only for additive manufacturing, because this is really the future. And here you can think in really very crazy dimensions, and it's possible. And we have major solutions, and it is already used for aerospace business, and many other customers are also taking use of the additive manufacturing. Just a small forecast, maybe you have any idea, you can ask me. I think they will distribute our contact, and just to give you a mind opener. Yeah, we don't need to talk about the machine. So yeah, we are at the end of the presentation. Sorry, we are a little bit too long, but we started earlier because the further sessions has not taken so long. So any questions for you? Or from you, for me?
Any questions can also be afterwards in the Q&A or even...
Okay, absolutely.
Yeah.
Great.
Nothing at the moment. I want to
Okay, yeah, then we go ahead. Of course, we go ahead with the program.
Yeah.
Thank you very much. Thanks again for the chance to tell you something
Thank you, guys.
from our point of view.
And now it's up to Mutitoyo.
Thank you well.